Equivalent fraction. Let us consider how to derive equivalent fractions. In these examples, we are going to look at two rectangles containing teapots. Note that in the green rectangle, there are 4 teapots, 2 blue teapots and 2 black teapots. The second rectangle is yellow and it has 8 teapots. 4 of these are blue and the remaining 4 are black. Now, we are going to compare the fraction of the black teapots in each rectangle. The total number of teapots in the first rectangle is 4. The number of black teapots in this rectangle is 2. Therefore, the fraction of the black teapots is 2 over 4. Remember, we defined a fraction as part of a whole. Let us look out for the definition in the answer. The whole or total number of teapots in the first rectangle is 4, and the figure forms the denominator, while the parts represented by the colored teapots are the 2 blue and the 2 black teapots. Since we are interested in finding fraction of the black teapots in this rectangle, this will be considered as the numerator. Therefore, from the definition of fraction, we can now say that the fraction of black teapots in the first rectangle is 2 over 4, where 4 is the denominator representing the whole teapots and 2 is the numerator representing the 2 black teapots. Looking at the second rectangle, there are 8 teapots. 4 are blue and 4 are black. The fraction of the black teapots in this rectangle is 4 over 8. Similarly, the whole or total number of teapots in the second rectangle is 8, and this represents the denominator, while the parts based on the color of the teapots are the 4 blue and the 4 black teapots. Since we are interested in finding the fraction of the black teapots in this rectangle, the numerator of the fraction will be 4. Therefore, from the definition of fraction, we can say that the fraction of black teapots in the second rectangle is 4 over 8, where 8 is the denominator representing the whole teapots and 4 is the numerator representing the 4 black teapots. By reducing the two fractions of the black teapots in these two rectangles to their lowest forms, we have 2 over 4 being reduced to 1 over 2, or half. Similarly, we have 4 over 8 also reduced to 1 over 2. Equating the fraction of the black teapots for the two rectangles, we can say that 2 over 4 is equal to 4 over 8 when they are reduced to their lowest form. In other words, half of the teapots in the rectangles are black. Let us consider another example. In this example, we will compare the fractions of red color inside two rectangles. The first rectangle is divided into 6 equal parts. 2 parts are colored blue and the remaining 4 are colored red. The second rectangle is of same length and breadth with the first rectangle, but this is divided into 12 equal parts. 8 parts are colored red and the remaining 4 are colored blue. Now let us find the fractions of the red color in the two rectangles. The first rectangle is divided into 6 equal parts. This represents the whole and it is the denominator. 4 parts are colored red, so 4 is the numerator. Since the fraction of the red colored part of this rectangle is equal to the number of parts that are colored red, over the whole part the rectangle was divided into. Hence, the fraction of the red color parts for the first rectangle equals 4. That is, the parts colored red over 6. That is, the total number of parts the rectangle was divided into. For the second rectangle, this is divided into 12 equal parts. This represents the whole and it is the denominator. 8 parts are colored red, so it represents the numerator. Again, the fraction of the red colored parts for this rectangle is equal to the number of parts colored red over the whole part the rectangle was divided into. Hence, the fraction of the red color for the second rectangle is 8. That is, the parts colored red over 12. That is, the total number the rectangle was divided into. Comparing the two fractions, we have 4 over 6 equals 8 over 12 when they are reduced to their lowest form, which is 2 over 3. The next topic is on how to calculate missing numbers.